Okay, welcome to question 12. So this one, find the solutions of 2 sine theta equals 1. So for this one, we just want to find what sine theta is by dividing both sides by 2. So we're going to go sine theta equals 1 on 2. This one you can just throw into your calculator. So just press on your calculator, press shift sine a half. And that will give you one of the answers, which should give you 30 degrees. Okay, and you go, oh great, I've got one of the answers. Now notice they want it in terms of pi because it's going from 0 to 2 pi. So you need to change this to pi, and that equals pi on 6. If you can always remember, pi, keep pi in mind for 180 degrees. So pi 180, divide pi by 6, pi on 6 is 30. Yeah? So it's saying you want that between 0 and 2 pi. Anytime you've got 0 and 2 pi, you can either draw your sine curve and go, okay, what are my two answers? Well, sine pi on 6 is positive, so that's about there, and I've got another one there. And you can sort of figure it out by that. An easier way to figure it out is to do this. Is to go, okay, that's 30, 30, 30, 30. I call this a butterfly diagram, so you should remember all stations to central and go, okay, this is positive, I've got a sine, so sine is positive there, and sine is positive there, and it's going to be negative there and negative there because that's tan and that's cos. So we're looking for this answer and this answer. So our first answer is 30, which we know we've got that, pi on 6, we can get that from the calculator. What's the second answer? Well, here's the second answer. So if we go 30 up this way, we want this answer. And that distance, or that angle there, is 150 degrees. And again, you've got to have it in terms of pi. So 150 is 5 pi on 6. So those are your two answers. And you're done. Question 12b, and there's two parts to this. We'll do one at a time. So the diagram shows a rhombus. The diagonal from the point A, which is there, to the point C lies on the line L. Now notice they're not giving you what C is. The other diagonal from the origin to the point B lies on the line L2, which is there, and they tell you the equation y equals minus x on 3. Show the equation of the line L1 is this equation, y equals 3x minus 10. So this is a rhombus. They don't give you any hints, but you should know your rules. Your rhombus rules say that that is a right angle. So you know that the gradient here is at right angles to this gradient. So we look at this gradient. So we've got y equals minus x on 3. So the gradient of this, or we can write it as y equals minus 1/3 x plus 0. And this is our form to recognise things in. This is the gradient. So because we've got a perpendicular gradient to this, we're going to flip it upside down. We can say m1 times m2 equals minus 1, or just flip it upside down and turn it negative. So we want the other gradient. So our gradient for line L1, call it m1, equals 3. That's going to be our gradient. We're going to put it into our equation, y equals mx plus b. So that is going to go there. Y and x they give us, they tell us one point on the line, which is 7, 11. So we're going to put both of those bits, x and the y, into this equation. So you're going to get 11 equals 3 times 7 plus b. Solve this with very simple algebra, that's 21. So 11 equals 21 plus b, and pretty obviously b is minus 10. So then we've got our equation. So y equals 3x minus 10, and look at that, we're done. Okay, 12b part 2. So you notice I've added in a few things. There's the equation, that's the other equation, and we've got d. So the lines L1 and L2 intersect at d, find the coordinates of d. It's pretty straightforward. You just make this equation equal to this equation. So we've got minus x on 3 equals 3x minus 10. Bit of straightforward algebra, multiply everything by 3, minus x equals 9x minus 30, add x to both sides, so 0 equals 10x minus 30, and 30 minus 30 is 0, so this must be 30, or you can put the 30 over here if you want to. So we're going to go x equals 3. Put this value into one of the equations, doesn't matter which one, put it in there. 3 times 3 is 9, take away 10 is minus 1, or you can put it straight in there. Minus 3 over 3 is minus 1, so you're going to get a value y equals minus 1. So that gives us our point, so d equals 3 minus 1, and you're done. G'day, back again, 12c. So for this question, find f dash x, where fx equals x squared plus 3 over x minus 1. Now, as you work through this problem, what you find is it actually puts you off a bit, and I'll show you why. To start with, you've got u over v, so that's pretty easy. You're going to go v to u minus u to v over v squared, and that bit should be pretty straightforward. You know how to do that. So you're going to go x minus 1 multiplied by, differentiate the top, and we get 2x minus u, which is x squared plus 3, differentiate the bottom, and we get 1 v squared, so x minus 1 all squared. Clean up the top a bit, so 2x squared minus 2x minus x squared minus 3, now all over x minus 1 squared. Now this is the step which I would think, if you're in the exam, or if I was in the exam, I'd think, is that right? Did I get this bit right? Because, take off that, you get x squared minus 2x minus 3 all over x minus 1 squared. And you tend to think, oh hang on, I can factorise that, and you can. So if you factorise that, what you get is, we get our x's obviously, and it's got to be 3, so it's got to be 3 times 1. You should have done that enough times to know that 1 times 3 is 3, and it's the only way you can do it. You've got to have negative 2 and you've got to have negative 3. So the larger number must be negative, and that must be positive. And that is the bit which would throw me off, because you've got this on the bottom, and you'd be thinking, hang on, should I have done that as a minus and be able to cancel it out? Well, in this case you can't. So this is your answer. But it's always good to check this and try and factorise this bit, just in case you can, because if they want to factorise that, they'd be wanting you to cancel that and cancel that. So if that had been a plus 2 there, then this would work out that you can actually cancel one of the x minus 1s. In this case you can't, but you just need to be careful of that in the future. G'day, back again. 12d. For what v is of k, does the quadratic equation x squared minus 8x plus k equals 0 have real roots? Well, real roots, you should remember, is usually figuring your discriminant. So your discriminant is a square root of b squared minus 4ac. And we're only looking for this, we don't actually need the square root. So just b squared minus 4ac. Well, there's your a, that's b, and that's your c. So b squared minus 4ac, so we want that bit. It's going to be minus 8 squared minus 4 multiplied by 1 multiplied by, or multiplied by k. And we want that to be either bigger than or equal to 0. So you just simply solve that. It's pretty easy. 8 times 8 is 64. Minus cancels out. Minus 4k is greater than or equal to 0. Add 4k to both sides, so we get 64 is greater than or equal to 4k, and divide by 4. So k is less than or equal to 16, and that's your answer. And you're done. G'day again, 12e. there's 4 parts to this bit, so we'll just do 2 at a time. The diagram shows the parabola y equals x squared on 2 with focus 0, 1/2, and tangent is drawn at 1, 1/2. They give you a nice neat diagram. It's interesting they always write not to scale in the Board of Studies, and I often wonder, you've had this for 6 months and you can't draw it to scale for the students. But anyway, find the equation of a tangent at P. Should be pretty straightforward. Equation should be looking at y minus y1 equals mx minus x1. So all we're missing is 1, 2, 3. Now they give you the point because we want the tangent there. So the only thing you're missing is the gradient. So in there is going to go, that's y, which is 1/2, and in there is going to go 1. So we're just missing that. So find the gradient. We've got the gradient of this tangent at that point. So differentiate it and substitute in the x value. So we've got y equals x squared on 2, so y dash equals 2 comes in front, 2x on 2, which equals x. So all we're going to do is substitute in the x value. In this case, the x value is 1. So therefore, the gradient m, which equals y dash at 1, equals 1. So that is going to go there. Put those in, and that's your equation. So then y minus 1/2 equals 1 x minus 1. Tidy it up. It's always best to have the x at the front and then the rest of the equation after it. So we've got y minus 1/2 equals x minus 1. I'm going to put all that over there. And I'm going to get x minus 1 minus y plus 1/2 equals 0. And the only thing you can join there is the 1/2. So x minus y minus 1/2 equals 0. And you're done. Second part. What is the equation of the directrix? Well, this should be easy if you know your parabolas. So they tell you that is the focus, and that should be a giveaway. If that's the focus, that distance there must be the same downwards to the directrix, which goes across there. Okay? So whatever that distance is there, it's the same distance there. Usually that's A. Okay, now we know that's 1/2, so therefore this is minus 1/2. So this equation of this directrix is very simple. So part 2, that's part 1. Part 2, y equals minus 1/2, and you're done. Back again, 12v part 3. The tangent and the directrix intersect at Q. Show that Q lies on the y-axis. Now I've put the directrix in there and I've written the tangent there. So we want to show that the tangent and the directrix intersect at Q, which is on the y-axis. If it's on the y-axis, x is going to equal what? 0. So if we can just show that that's on 0, we're done. So we've got x minus y minus 1/2 equals 0. We want that to intersect with this thing, which is y equals minus 1/2. So if we substitute that in there and find out what x is, so let's do that. X minus minus 1/2 minus 1/2 equals 0. Well, minus minus is a plus. Plus 1/2 minus 1/2 is nothing. So therefore, x equals 0. Therefore, they intersect on the y-axis. And you're done. Part 4. Show that triangle PQS is isosceles. Well, that's pretty simple. What we've got to do is show that that distance equals that distance, which it does because you know that's 1/2. That's 1/2. 1/2 plus 1/2 is 1, and that distance is 1. So you can simply just say that by saying distance S 0.5 over to P 1.5 equals 1. Distance S 0.5 to Q, which is 0 minus a half, also equals 1. Therefore, isosceles, since side lengths are equal. And you're done.